So stars typically don't form by themselves. As we saw when we talked about the formation of stars, the clouds of gas that typically form the stars clump up. And so you end up with multiple stars forming about the same time. Well, that gives you a star cluster. And so these a star cluster is basically can be thought of as a group of stars that formed about the same time out of the same basic overall nebula in the same star forming region. Star clusters are often categorized in a couple different ways. As with many things in astronomy, you categorize some things by how they look, and then other things by physically what's different about them. Astronomy, observational science, a lot of this is done by how it looks. And so star clusters were originally classified into two groups based primarily upon their appearance. So what we have are open star clusters, which are kind of loose collections of stars, and globular star clusters, which are these balls of very tightly packed stars. And it turns out they're fundamentally different kinds of objects. So we'll start with the globular clusters first. They're generally low metallicity stars. That means they are population 2 stars. They're very old stars. They're among the first stars that formed in the galaxy. One of the things we discover is that what makes a star is you got nuclear fusion, hydrogen fusing into helium. And then as the stars age, eventually the helium fuses into carbon and oxygen and neon and silicon and iron and all the other things that are out there. So when those stars die, some of that stuff is seeded into interstellar medium, so the next generation of stars has more of the things other than hydrogen and helium. And so globular clusters, because they have less of that other stuff, they're mostly population 2. They're very old. They're 10 gigayears. That's 10 billion years old or more. They form a halo around the rest of our galaxy. So our galaxy is kind of like a fat pancake here with a bulge in the middle, and the globular clusters form this halo around it. And your typical globular cluster is this ball of stars that is at most a few hundred light years across. And that sounds really big, but they have between 100,000 to 1,000,000 stars in them. That makes them really high stellar densities. Remember, the nearest star to us is over 4 light years away. So that means if you were to draw a sphere surrounding the sun of radius 4 light years, only the sun would be in there. If you draw a sphere radius about 4.5 light years, now you have the sun and Alpha Centauri. Now, Alpha Centauri, we know it's a triple star system, so technically it'd be 4 stars in that sphere. But you draw a sphere the same size in the middle of a globular cluster, and you might have several dozen stars in there, maybe 75 to 80 or even more stars. And so much higher stellar density. In fact, there's a question, if you had a planet orbiting a star in the middle of a globular cluster, would inhabitants of that planet really understand the concept of night? Because there'd be so many stars in the sky that the sky would be bright at night as well as during the day. Because the globular clusters formed about the same time our galaxy formed, then they are very important to understanding the history of our galaxy. So understanding our galaxy means understanding globular clusters and how they fit into the star forming at the beginning of the galaxy. Globular clusters themselves range from sparse, like M11, which is barely a globular. It's blobs of stars there that's in a roughly spherical shape, but it does not have that many stars in them, to something like Omega Centauri, which is so big and so dense and so bright that it actually looks like a fuzzy star. That's why I call it Omega Centauri. That's a Bayer designation. It's very far south in the constellation Centaurus, and so from Europe, it's hard to see that it was not just a fuzzy star or a star. It's visible to the naked eye. A couple of these are visible to the naked eye. In Hercules, if you're in really, really, really dark skies, you can see in the constellation Hercules a sort of fuzzy patch. And in binoculars, it shows up as like a little cotton ball looking thing. And that's actually a star cluster, a globular star cluster. Uh, One of the most distant globular clusters to us, NGC 7006, is a challenging object to see in the telescope. So M13 is another star cluster here. This is one that's you can actually see with the naked eye. So if you know where to look in really dark skies, it's really easy to see in binoculars. Even in the city lights, you can often see this in binoculars. You can see it easily in a small telescope. And the way that you find this is you find the constellation of Hercules, and the bright star Vega is in Lyra, and so it's on the other side of Hercules between the two stars. Now Hercules, the outer parts of Hercules are dim to see, but Hercules is often seen as a big trapezoid in the sky. So how would you find Hercules? Well, you actually have the tools. I've posted on Blackboard a map of the sky. The way you use this map of the sky is if you want to face towards the east, turn it where east is at the bottom, and you can hold it up, and you notice that right in the center is a little dot, a little X. That's the zenith. That's directly overhead. Hercules is almost at the zenith, and so that means you would hold this up like that, and almost straight overhead, just a tiny bit to the east, is going to be this big trapezoid or keystone shape in the sky. That is going to be Hercules. Another tool that you have is the Mag5 Atlas. I've actually scanned this for you. So map 6 of the Mag5 Atlas shows where Hercules is and shows where M13 is. By the way, M13 is also marked on this little sky map right here, the evening sky map. The evening sky map, this would be kind of, it tells you that you go out here, this is going to be late June, kind of close to 10 p.m. or so, so a little bit after sunset, you'd see it kind of like that. We talked about how to use time and the sky with the Mag5, so you can use that to figure out where it is. But even in binoculars, if it's dark enough that you can see the stars that make up Hercules, you can easily find M13 in binoculars. And so what you would do is you would find the side of that trapezoid that is opposite of the bright star Vega, and about a third of the way from the northern star in that trapezoid is going to be the star, rather the star cluster M13. And so you can actually do that, find it, and posted on Blackboard is a binocular observing worksheet. What you could do is, for extra credit, go out and observe this with a small telescope or binoculars if you have binoculars, and look for it and sketch what you see. And you can email and ask questions for exactly how to fill out the worksheet. But what you would do is you'd sketch that and submit that for extra credit as an observation here of M13. It's one of the easiest of the globular clusters to see. So I would recommend you go for that.